Friends, welcome to the class. Today we will discuss about frustum of a cone. The definition of frustum states that if a right circular cone is cut off by a parallel plane to its base, then the portion of the cone between the cutting plane and the base of the cone is called frustum of the cone. Let ABC is the right circular cone which is cut by a plane parallel to its base with center O and the diameter AB. After removing the portion containing vertex C, the left portion A, B, B dash, A dash is called frustum of the cone. So as it is clear from the picture that ABC is a right circular cone. When if the cone is bisected by a plane parallel to the base, then after removing the vertex of the cone, the left portion is called the vertex. Like in this picture, this A, B, B dash, A dash. This is a vertex. Sorry, this is the frustum. The frustum of a cone has two unique to unequal flat circular base and the curved surface area. Height of the frustum. The height of the frustum is the perpendicular distance between two circular bases. They have a picture OO dash, or you can say it is OO dash into CO and CO dash is the height of the frustum. This is the distance between these two. Perpendicular distance between these two, the circular base is called height of the frustum. Slant height of the frustum. The slant height of the frustum is the length of the line segment which is obtained by joining the endpoints of the two parallel radii in the given picture A dash, which is equal to CA minus CA dash is the slant height of the given frustum. So here slant height is nothing but A dash, or we can say B dash is nothing but the slant height of the given frustum. Some important formulae. Let H be the height, L be the slant height, and R1, R2 are the radii of the circular ends, such that R1 greater than R2 of the frustum of the cone. Then the first one, the curves or the lateral surface area of the frustum is pi into R1 plus R2 whole into L, where L is nothing but square root of H square plus R1 minus R2 whole square. Second formula, total surface area of the frustum is pi into R1 plus R2 whole into L plus pi R1 square plus pi R2 square. Now volume of the frustum is 1 by 3 pi I H R1 square plus R2 square plus R1 into R2, and area of the metal sheet used to make a bucket. Why bucket? Because bucket is nothing but a form of a frustum. It is nothing but outer or inner curved surface area. If it is hollow, then we can say only the inner surface area plus area of the bottom. So it is pi R1 plus R2 into L plus pi R2 square. Here, anyone, this pi R square may be anyone, R1 or R2, any one of the area of any one of the radius, any one of the circle. Let's see some example. If the radii of the circular ends of frustum of a cone are 20 cm and 12 cm, and its height is 6 cm, then find the slant height of the frustum. So given that R1 equals to 20 cm, R2 equals to 12 cm, and H is 6 cm, we know that the slant height of the frustum is given by L equals to square root of H square plus R1 minus R2 whole square. So putting the value of H, R1 and R2, we get L square is nothing but square root of 6 square plus 8 square, which is not square root of 10 square, or L equals to 10 cm. Thus, slant height of the frustum is 10 cm. Is the answer. An open metal bucket is in the shape of a frustum of a cone if the diameter of the two circular ends of the bucket are 45 cm and 25 cm, and the vertical height of the bucket is 24 cm. Find the area of the metallic sheet used to make the bucket. Also find the volume of the water it can hold. given radius of the two ends of the circle are R1 equals to 45 by 2 centimeter and R2 equals to 25 by 2 centimeter and H is 24 centimeter. We know the slant height of the frustum is given by square root of h square plus r1 minus r2 whole square, or putting the values we are getting, it is L equals to square root of 24 square plus 45 by 2 minus 25 by 2 whole square, which is nothing but 26 centimeter. Now area of the metallic sheet used to make the bucket equals to lateral surface area of the frustum, or it is nothing but pi into r1 plus r2 whole into L plus pi r2 square, or putting the values of r1, r2 and L, we are getting it is 22 by 7 whole into 45 by 2 plus 25 by 2 26 plus 22 by 7 whole into 25 by 2 whole square, which is in fact 3,351.07 centimeters square. Now volume of the water the bucket can hold is 1 by 3 pi h whole into r1 square plus r2 square plus r1 into r2, or it is nothing but 1 by 3 into 22 by 7 whole into 45 by 2 whole square plus 25 by 2 whole square plus 45 by 2 into 25 by 2, which is equals to 23,727.57 centimeter cube. Thus, the area of the metallic sheet is 3,351.07 centimeter square, and volume the water can hold is 23,728.57 centimeter cube is the answer. The height of a cone is 30 centimeter. A small cone is cut off at the top of the plane parallel to its base. If its volume is 1 by 27 of the volume of the given cone, then find at what height above the base the section was made. Let's draw the picture first. Let BAB is the cone and the height BO equals to 30 centimeter and the radius of the base is r centimeter. Let it is cut off by a plane parallel to its base at a height h from the base. So we got a small cone V A dash B dash. Let the radius and height of the smaller cone be R1 and H1 respectively. So in triangle BOA and triangle BO dash A and A dash A, we have angle BOA equals to BO dash and A dash, which is nothing but 90 degree, and angle BAO equals to angle B A dash O dash because corresponding angles. So we can say triangle BOA is similar to triangle BO dash A dash, or you can write BO by BO dash equals to OA by O dash A dash. Putting the values, we can get 30 by H1 equals to R by R1, or actually the question volume V A dash B dash equals to 1 by 27 into volume of VAB. Now putting the values, because volume of a cone is nothing but 1 by 3 pi R1 square H1 equals to 1 by 3 pi R square into 30. So we can write R1 by R whole square into H1 equals to 10 by 9, or H1 by 30 whole square equals to into H1 equals to 10 by 9, or H1 cube equals to 1000, or H equals to cube root of 1000, 10 centimeter. Now H is nothing but 30 minus H1, or it is nothing but 30 minus 10, which is 20 centimeter. Hence, the section was made at a height of 20 centimeter from the base of the cone is the answer. A solid cone of base 10 centimeter is cut into two parts through the midpoint of its height by a plane parallel to its base, but ratio of the volume of the two parts of the cone. Let's draw the picture first. Let ABC is the given cone with radius BP equals to CP equals to 10 centimeter. The cone was cut into two parts through the line passing through DE. That means D is the midpoint of AB and E is the midpoint of AC. AP is the height of the cone and the line segment DE intersect AP at point O. Let BP equals to CP equals to R1 and DO equals to EO equals to R2. AP equals to H1 and AO equals to H2. Now given that in triangle ABP, D is the midpoint of AB and also OD parallel to BP. That means DO equals to 1 by 2 of BP and AO equals to OP. And this is first equation. So putting the values, we can write R2 equals to 1 by 2 R1 and H2 equals to 1 by 2 H1. Or we can write 2 R2 equals to R1 and 2 H2 equal to H1. Okay, this is second equation. Now volume of the cone ADE is 1 by 3 pi R2 square into H2, because volume of the cone is 1 by 3 pi R square H, and volume of the frustum is 1 by 3 pi H2 4 into R1 square plus R2 square plus R1 R2. So the volume of the cone by volume of the frustum is 1 by 3 pi R2 square into H2 whole divided by 1 by 3 pi H2 into R1 square plus R2 square plus R1 into R2. Now in both numerator and denominator, 1 by 3 pi and H2 gets cancelled, or we get R2 square whole divided by 4 R2 square plus R2 square plus 2 R2 square, because from equation 2, 2 R2 is equals to R1. So R1 square in the place of R1 square, you can write 4 R2 square, and here in the place of R1 you can write 2 R2. So it becomes, in the numerator only we are getting R2 square, and in the denominator we are getting 7 R2 square, which is nothing but 1 by 7. Hence the required ratio is 1 by 7, or 1:7 is the answer. Friends, here we saw a few questions, few examples. Practice more and more such questions, and in case you come across any difficult question, feel free to share your question with me. It will be a pleasure for me if I can help you out in solving your doubts and solving your question. So this was for today's class. Thank you.